Hello, welcome to ToddFun.com, where I do what I think is fun. And this week it's going to be, well, I hope it's the last time on this power supply repair for the treadmill slash converted lathe. This is the power supply control. You can go back about over a year now. I've pulled this out of mothballs to poke around at to see if I could fix, probably about 5 times now. Never really had any success, so go back to the previous power supply repairs to see where I've documented the different types of components on here, what I think the problem was, and how I got different things working and not working. Hopefully this is the last one. I say that because everything keeps pointing back to the current mode pulse width modulation control chip. That basically is the heartbeat for this, as well as the feedback for the heartbeat, or essentially the rhythm of how fast the motor turns under load. Of course, originally it was for a treadmill, and now it's for a metal lathe that's been, as I've done in other videos, this has been altered to control a lathe, a little mini lathe. Now, if you want more detail about all that, yes, please go back and look at the other videos. I'm not going to cover that again. I'm just going to say that I've taken the actual pulse width modulation chip off. It's where that little footprint is right there. That's the current mode pulse width modulation chip that controls the power MOSFETs on this board. That's all documented earlier. Yes, I replaced it and it didn't fix it, but then I went essentially 4 more posts after that, troubleshooting everything else on this board and finding nothing wrong. And well, I originally thought it was the pulse width modulation chip, and I still think it's the pulse width modulation chip. And I just went out and ordered 4 more. And here they are. Got them from DigiKey the other day. I'm going to do like I previously did. I'm going to test one on the circuit board. In fact, I had done that. I had tested one on the circuit board, and they actually was testing out fine. I had 2. One was in here, and one was on the breadboard being tested. And while testing one on the breadboard, I turned the wrong knob, and you can see how it fried it. That middle one is fried. So on here is the original one, which doesn't work, the one I fried, and the one that came out recently. And all 3 of them test differently for different failures. So I still think that my problem is the pulse width modulation chip. Somehow I managed to damage the one I put in there. So I'm going to show a couple tests of why I think these are bad. Then I'm going to drop one of the new ones in, and sorry it took a year, but it should be working fine. So let's get to it. Okay, I'll try and keep this short. These are a set of 4 of those chips, the current mode pulse width modulation control chips. From the bottom, this is the one I've been using and testing in the last, essentially all the videos, because I replaced it right away. But I'm going to show now why it definitely is not good. This one is another brand new one that I was going to put in the board, but I wanted to test it first, and I reached for the wrong knob and blew out the side. This is the original chip that came from the factory, and it is not working for us at all. And this is a brand new one from DigiKey. So I'll set my fluke here to diode mode, because inside these chips there's there's control transistors. See if I can put it here. If you pull up the data sheet, this is pin 7 on an 8-pin chip. That's 7/13. The 7 is pin 7 on an 8-pin chip, and this would be 13 on a 14-pin package. But on pin 7, there's a transistor here that will basically take your VCC in, and when this logic gate says it's good to pull this transistor on, then you'll have VCC out right here at pin 6. And at the same time, this transistor will turn off because it's sort of a flip-flop mode. Then you will have nothing, this will turn off and nothing goes to the ground pin 5. Likewise, when this switches the other way, then this turns off internal, because this is internal to the chip, and VCC cannot get to the output pin, and pin 6 is pulled to ground. through this transistor being turned on, because they're essentially being reversed between this output logic and this output logic. So that's just what I'm going to show is goofy with a little bit of a test. This is in my diode test right now. And if I take the brand new chip, and I've got it in the breadboard only so it makes it easier for me to test. If I plug into pin 7 with red and I go into pin 6, I get nothing. And even if I go down straight across to everything to pin 5, so between 7 and 5, I get nothing. And likewise I get nothing there. And if I go down to the chip that I had been using in the board and I go pin 7 and I go pin 6, nothing. And then I go pin 7 to pin 5, which is ground, it's shorted out. So this chip is shorted out. Another little test is you can switch these around. So now I have my ground for my diode test at pin 7, and I can go into pin 6 and I get a 0.7 volt drop. Likewise, I get a 0.5 going to ground and a 0.6 going from pin 6 to pin 5. But you saw what was inside the chip from the datasheet. And if I go down to the chip that we were trying to make work, and I do that, pin 7 to pin 5, I get nothing. Or pin 7 to pin 6, I get nothing. And then of course I still have a ground no matter which way I go, from 7 to ground. So my VCC was literally shorted to ground in this chip. So this chip, even though it was factory new, I managed to damage it in some way, either by overheating it when I put it in, or by not being properly ESD grounded at the time, which I am now. So we'll put this one in and fire it up and see if everything's working with this proper tested current mode pulse width modulation chip. Okay, I got my new chips here. Go ahead and put it in. I've cleaned up the surface a little bit so it's not quite so dirty. The chip's in there pretty tight. Okay, hope that looks good on camera. Now we're going to hook it all up to the motor and give it a test. Okay, we're all hooked up for a test. These wires here, the orange, blue, and gray, they just go down to a lid that has a pot that you just rotate that controls the speed. That's on the lid. That was retrofitted. And we have power coming in from the 120 mains, which is actually hooked up to my isolation transformer for safety. The red and black come off the control board and actually give the 90 volts DC to this motor. Pulse width controlled, of course, by that one chip and these power transistors. And then this blue and brown coming off of this magnetic pickup on the back of the motor determines how fast this will spin. Ooh, it's got a little spinning. Yeah! That takes off. I put a piece of tape on it so it's a bit loud. It is a little sensitive. Okay, I will definitely call that a success. Let me take that tape off. Okay, so it won't be so loud now. And that kicking over where you hear it go really fast and then I can turn it back down again, that's basically it's getting too warm. I don't have any of the heat sinks on, and we have to make sure that there's some airflow over top of this board, because what's happening is those chips get a little warmed up, and then that basically changes the voltage levels inside the control module. And of course, as soon as those temperatures heat up, then the speed it basically gets all discombobulated in what the actual feedback voltages are. But that won't be a problem once it's mounted in its box and it has all of its heat sinks hooked up and has good airflow. Then that should regulate better. It'll still be slightly of an impact, because it's always going to be somewhat temperature sensitive control board, but it'll be greatly reduced from just having it naked with no cooling, no heat sinks, no nothing. So, well, there we go. It's fixed. This variable speed motor control and power conditioning board is now fully working. It took a year piddling on it once in a while, every 3 or 4 months, posting up on what I thought I'd figured out. All of that trouble, all of that headache. Very beginning I thought it was the PWM chip because that's where it traced down to. Replaced it with a brand new one. Somehow I damaged it. Either ESD damaged it. This time I was a lot more careful with my ESD, or some other way it was damaged. At any rate, it was damaged for the whole year. Got another brand new one in there because it still was that. Boom, this board is working great. Once we get those heat sinks on, like I said, it'll stabilize the temperatures of the components that get too warm. Get some holes drilled in there for extra cooling on this. And this thing is back in service, and we'll be powering a mini lathe again in a matter of days at Heatsink Labs, where they're waiting for their motor control back for their little mini lathe. So thanks for joining. Hope you learned something. It was painful, but sometimes that's how this stuff goes. Too bad it wasn't a whole lot more interesting or easier. I would have got it done earlier. Actually, it was just baffling. So, and it wasn't that much of a needed board. So that's why I kept putting it off. But now they do need that mini lathe, and so I did step up my my efforts to get this figured out. And I'm glad I did. I got it worked out. I can check off one more thing that won't go in the landfill, and back in service. Thanks for joining. Bye.